value of 4 is 4. Is the absolute value of a negative 4 also for an answer? 4. For absolute value. Okay, so that's the essence of absolute value altogether. So with that said though, let me remind you what that graph looked like back then. It was a nice V-shaped graph. Something like this. I gotta replace this for a reason. Let's see if my markers will hold it for me. Because I gotta do something with that graph after I get it. This V-shaped graph that looks something like this. That's a shape. I could place arrows on the ends. It goes on forever. We'll just leave it like that. That's a V-shaped graph. Please tell me, is all of that red graph, is it all above the x-axis? Yes. If it's above the x-axis, that represents what? Positive. That's why those kids across the street, all they know is positive. They say, I know absolute value always gives me a positive answer. Now you, coming back across the street to here, you know why, it's always above the x-axis. Except at 0. It's right on, 0. So the absolute value of 0 is 0. So that tells me that. Now, on the side here, they're saying, now please, part B, solve some equations containing absolute value. Now on the handout there, Johnson, I'm going to look at my notes. I may have written down many of them right directly from the handout. Did we, hang on, we did, I think. Let me start with this. This may not be on the handout. Guys, if I solve this, based on what we're doing here, the absolute value of x is equal to 12. Solve for x. What it comes down to, what can you replace x by inside there, and be guaranteed when you do the absolute value, it comes out to be a 12.
Plus or minus 12.
Plus or minus 12. I can place either a positive or a negative 12 and be guaranteed inside there, after you take its absolute value, it's 12. Now, to point out right quickly, if you're asked to solve this one, now what am I guaranteed to put inside there and do that absolute value business on it and get an answer of a negative 12? Nothing. Absolute value is never negative. It cannot give you a negative answer. That's what the graph shows. So here, no solution. Nothing. Not even imaginaries here to deal with. Number 3. You want to see what's going on here with these absolute values. They're not hard. Next one looks like this. Absolute value, 2x subtract 1 is equal to 5. Solve for x. Now you might sit there and say, wait, Professor, can I just guess? You could guess. Some of the problems may get tougher though. There should be a little routine to find it. I see right now, just standing here, if I should replace x by 3, 2 times 3 is 6, 6 minus 1 is 5, that's going to work. And I think there's another number that will work. Before I actually show you how to actually find them, just by guessing, 3 works. Does anyone have a guess for the other one?
Negative 2.
Negative 2. Put a negative 2 in there, that's negative 4. Minus 1 is a negative 5. The absolute value of negative 5 comes out to be a positive 5. That's what I'm looking for. If I didn't see that, you could do this. You say, well, Professor, 2x minus 1 inside there could be a 5, or 2x minus 1 inside there to make this work could be a negative 5. This is both 1, 5, and negative 5. If I solve this one, guys, we'll do it quickly. This is the 3 I think I was talking about. If I solve this one, I think you end up with, like I heard earlier, negative 2. That's a quick way to find it. You're done. Okay. Number 4. Take this one of these. absolute value of, now it gets a little tricky on this one. Absolute value, x squared plus x is equal to 12. Now, I don't want to stand here myself this time and try to guess. So let's come up with a routine here and actually try to find what will all that inside there be equal to make a 12, what's the 12 here? Yeah, 12 come out. Who has an idea? Eric?
Set them both equal to 12 and negative 12.
Okay, first, you say, well, professor, you could set the x squared plus x equal to 12 inside there, that would give you a 12. Or, put it down here, the inside could be a negative 12. So that x squared plus x could be a 12 or a negative 12, it'll work out. You gotta solve each one. Now make it some crazy here. This is, look at this, when I solve this one, it's a quadratic. X squared plus x, I'm gonna move the 12 over, we're back into quadratics. Thinking of this one factors. X plus 4, x subtract 3. Split that up, you guys have answers of negative 4 and a positive 3 at this moment. Should work. Leo, hang on. So far, so good. Okay. Now, you could have guessed at those numbers. Now, Eric was telling me, hold on, professor, also you can consider a negative 12, where am I? For this to be representing, if it were all representing negative 12, so Racing put a negative 12 in there, the absolute value is also 12, so that's another consideration. Guys, this one, if I try to solve it, looks like this. Move the 12 over, come to plus 12. So solve that quadratic. This one will not factor. So I could attempt to do what? Maybe quadratic formula, and watch what happens on this one. X is equal to, by quadratic formula, negative 1 plus minus square roots 1. Subtract 4 times 1 times 12 all over 2. Can someone tell me an issue already?
You're gonna have a negative inside.
I'm gonna have a negative underneath that square root, which says imaginary numbers, and you cannot have imaginary numbers coming out for an absolute value. So that's ruled out right quickly. Can't use it, we tried. This is done. The only two answers are on this one was what, negative 4 and 3. Done. Back this over here. Negative 4 and 3. Guys, any questions right now? Can't go wrong. I don't think it can go wrong. Because absolute value just shows there is a possibility of two situations happening here. I think I did throw in one more, Jonathan, you can check and see if I did, this may have been on the handout. And I got the board really covered up here already, so I gotta be careful. 1, 2, 3, 4, this is my number 5 here. And my last example here, absolute value, 2x plus 1 over 3x plus 4 equals 1. Jonathan, was that on the handout or not?
Yeah.
Okay.
Yeah, that's part of the.
We'll solve. Now guys, I'm not gonna sit here or stand here and guess. I need a routine. So tell me, please, it all depends upon that inside part. What are the possibilities of set this up? What about this that I can do? What is that? What can I do here? Give me one, Leo, tell me one setup here.
You can multiply the denominator by the denominator.
Okay, well, tell me again first though. What can I write down? Because back here I wrote down this.
Separate.
Here, I got separated. So tell me one of the separations.
2x plus 1.
2x plus 1. Tell me more. Over 3x plus 4, all that could be equal to what? 1. If all that's representing 1, that statement's true. The absolute value of 1 is 1. Another possibility to make it work, I'll put it over here, if what? What else could be inside there? If all this were missing, 1 could be placed inside for sure. What else could be placed inside if this were missing to get a 1 to come out for an answer? -1. Is the absolute value of -1 also 1? Okay, so I could say, hold on, Professor, that's 2x plus 1 over 3x plus 4 could also be representing -1. The inside part can be negative. It's the final answer coming out cannot be negative. Are those the two cases, guys?
Yeah.
Easily set up. Now I'm gonna solve each one here. Guys, go back to the first one. You guys can multiply both sides by 3x plus 4, or you can move things around, come up with a common denominator so many different ways. I'm going to do it like this. Let me erase this, so I have room. I'm going to multiply both sides by 3x plus 4. And here. This is cleaned out. Those 3x plus 4s will cancel on the left. That's why I want to do it. Leaving me 2x plus 1, and of course on the other side we left out just 3x plus 4. Trying to solve the equation. I'm multiply both sides by that denominator. I move things around. I'll do it fairly quickly, guys, and move mine like this, and you guys can do this later. Looks like, if there's no mistake, one x value is -3. I'm looking at it. Okay, and I'll check it later on. Looks like it's -3. The other one over here, I'm going to use the same routine. Multiply them, erase that. Multiply both sides by 3x plus 4. That's like my denominator, common denominator. They'll cancel on the left, which I want. Now on the right, what happens if I multiply the right, which is -1, also by 3x plus 4? What am I going to end up with? I got -1 over there, and I'm multiplying both sides by 3x plus 4. What's going to happen on the right?
-3x minus 4.
-3x minus 4. I'm multiplying through by -1. No problem. 5x is equal to, looks like -3, -5. Oh, cute. X is equal to a -1. Step back and look at it, make sure. Looks good. Looks good. Oh, these are our two answers. Just solving equations. We spent so much time on solving equations earlier in this class, my first week. Are we okay? Now, if you have the time, I'm not gonna write down the board for you, but if you have the time, you can easily say, wait, Professor, I'm gonna quickly go back and put in a -3 back here for those x's in the original. A -3. Guys, help me out here. 2 times -3 is a -6 plus 1 gives me a -5 on top. Put a -3 down here, that's a -9 plus 4. And -9 plus 4 gives me what? -5. And we had on top also a -5, didn't we? And what's a -5 over a -5? 1. And the absolute value of 1 still remains 1. This one, -1's, try -1 for a check. Replace x by -1, 2 times -1 is -2. -2 plus 1 makes that numerator -1. Right, -1. Put the -1 down here, I get -3 plus 4, I think it's a +1. So I got -1 numerator, +1 denominator. Is that all together -1? Now use the bars, take the absolute value, does that also turn into 1? They both check. They both check. How can you go wrong? If you miss one of these on the exam, you go wrong or write on paper, you went wrong. Gee. Jonathan.
In terms of what you said, x equals -1, where did you get that again? I know it's probably simple, that's all.
Right here,
Yeah.
I solved the equation.
Was that just for?
I just moved that over.
Oh, okay, right, you moved it and then.
That?
And you added that, okay.
Yeah.
I got it, okay.
Just solve the
Just
equation.
making sure.
That's all I did. Pretty good? Now, to finish up the handout, on this absolute value, we should finish up chapter 2 altogether. They're saying now, guys, do this, and I have a unique way to show you this. Let me erase and get some space here. So, guys, this is our second week ending. If you were doing this class in a regular 16-week spring semester, let's say, they would not be doing this in that spring course. What we're doing right now in the second week here, I think it's not until the beginning of the fourth week for sure. We would not be going into this till like maybe the fourth week. Now we're doing it in the second week of this fast course here. Okay, guys, on inequalities. You say, oh, Professor, my goodness, you showed me how to solve an equation with an absolute value. And now all of a sudden you're saying, okay, how about an inequality? Let me erase all this so we don't look at it. Now, here's my unique way to do this. I wish the textbook, they may have done this. The textbook, I don't think it did though. We're going to go back to that V-shaped graph. I'm going to do something with it. I'm going to draw a line and ask you a few questions. I'm going to do this in green, guys. I'm going to draw a straight line, horizontal line, straight across. Like that. Okay, and I'm going to say that that line, horizontal line, is up at 2. Let's call it y is equal to 2. So a little bit straighter. Okay. Y is equal to 2. Now just do that out for an example. You can go up to 3, up to 4, whatever. Now, can anyone tell me the intersection points with my absolute value graph, the red one, that represents this? There's 2 intersection points. Can anyone venture and tell me the coordinates of those 2 intersection points of y is equal to 2, horizontal line, with my red graph, the absolute value graph?
Negative 2, 2, and positive.
Whoa, whoa, whoa. Negative 2 here. Eric says up 2. Professor, this must be positive 2, up 2. Will those 2 satisfy both? This, if I take the absolute value, will those 2 satisfy the absolute value? The absolute value of negative 2 is 2. Satisfied. The absolute value of positive 2 is 2. Satisfied. And my green line, merely y is equal to 2? Yes, y is equal to 2 in both of those. So he's giving me the points to work with. Now, Jonathan, here comes one of your favorite things. You and I have talked about this so much. Now, I'd like to have someone to tell me the answer for this absolute value inequality. Am I right? I'd like to solve this. Absolute value x is less than 2. Not equal to 2, less than 2. Okay, someone look at that graph and tell me, reading math, I call it reading math. Can you read a graph and tell me what on that graph does it mean I'm looking at to answer this question fairly quickly, and then I'll shade to show exactly what is happening here. So guys, absolute value of x is less than 2. Can someone first tell me in your own words, translate, what does that mean? Just in your own words, not necessarily math. What does it mean?
When are the x values on the graph less than 2?
Well, it's something else. Even easier.
When is x less than 2?
No, easier. You see that,
When
and
is
that's
the
the
graph?
trouble with math. Sometimes we overlook it. Sometimes it's easy, sometimes it's not. But sometimes we overlook when it's so obvious.
When is
I've
the
done that
graph
myself.
above the
This is
green line?
obvious. It says, and let me do this then. I changed this to 2 instead of green. Let me change here to the green color. Because I had those colors. Someone tell me in your own words, Corey, what does this mean?
When is the red under the green?
There you go. When is the red under the green? That's all it says. When is the red under the green? Corey, thank you. And I'm gonna shade in to show you where that's happening. See if you guys agree. The red must be underneath the green. Please tell me, is he telling me, Professor, this part here of the red is beneath the green? Is that the part of the graph that's beneath? Now, can you tell me from the extent from what to what is that happening?
-2 to +2.
Look at that. Look at that. The professor. It's -2 over to 2. Open. It goes from here to here for the x's. That's what they said, solve for x. That's where the x's are. It goes from -2 to 2. Corey, here goes. Number 2. I'd like to solve this. Absolute value of x is, let's throw in greater than or equal to 2. There's my red. And this time though, let me put my green here. Greater than or equal to 2. Corey, you did such a beautiful job. Tell the class in your own words, what am I looking for this time?
When the red is above the green.
Jeez. When the red is above the green. That's all I want you to know. When is the red above the green? Now, when the red is above the green, I see where it is, but I got shaded in to make sure we all see it. Let me see if black markers will work. Above, guys, the red is above the green. I see the red, I see the green. This piece is above the green. This piece of the red is above the green. Now, can anyone tell me when is that happening, Leo?
-infinity to -2, open.
Will be bracket, I think.
Bracket, yeah.
And
Union, bracket to positive infinity.
I'm there, that's the mathematician in here. That's all it means. That's all it means. Corey, I appreciate you. He said a little common sense. Just look at the graph, Professor. Just look at the graph and look at it. I'm telling you where it's above or below. Jonathan, remember that first stage? Yeah, that's all it is. When is it above? When is it below? The red's above, red's below. It tells you what's happening here. Now, that's what it's to do for us. It's going to open up an easy way to solve the inequalities coming up to finish up this chapter. Guys, here we go. I think a good way to do this. I'm going to do it right now. Yeah, I am. Bear with me. I'm going to go back and now make a general statement, not just this particular example, a general statement. I'm going to call this up here, rather than just 2. Let me erase my 2's here. That was my nice example I had. Let me erase that. Let me keep my graph. Let's say, just in general, let's call this, I think the textbook calls it just A. Where A could be 2, A could be 3, A could be 4. Just let's pick them all up. And just represent them with an A. So A can be replaced by any of those numbers. Now, if anyone tell me now, be careful, how would you label this intersection point, do you think? At this point, now, that on that V-shaped graph, absolute value, and my horizontal line might be labeled as what?
XA.
Okay, XA. I'm here at X. A. Over here it might be labeled as negative X. I hear, I think, A. You guys agree? At least they're labeled. I think there's something else here to do. Let's see if I'm ready. Okay, here we go. Trying to make sure I've changed it a little bit here. I gotta do this. Corey, I'm gonna erase this beautiful work you did here. I'm gonna try to make a general statement of this. I may have to go back and modify this a little bit, guys. Now I'd like to come up with, just in general, if I see absolute value of x less than, not necessarily a 2, Professor, it could be a 3, could be a 4, could be a 5. We'll just call it A. So I can sort of look at and use this technique on any number, not just a 2. So the absolute value of x is less than A. Corey, you told me that was when the red was below the green.
Yep.
I know I've marked this thing up a little bit, right? The red was below the green. And he told me earlier, Professor, it happens from here to here. Oh boy, let's try to do this. Here we go. Let me change this right here. Will look better. Guys, I'm gonna call this A. I think I'll call it 2, 2 for my example. Was it 2, 2?
Yeah.
Yeah. And this down here, let's call it what? Negative A. I think I call that negative 2, 2. Let's try to come up with a general statement, okay? I can think of it way here. Corey, help us out. Now with those, at new marking, can you tell the class when is my red graph below that green y is equal to A horizontal line?
From negative A to positive A.
Negative A to positive A. He said perfectly.
How come it's not bracketed?
Hang on, I don't have an equals mark. I just put an equals mark.
I only thought that because the point.
It would be right on the graph. I just wanna know when is it below. I don't wanna know in this case when it's right on the graph. If I had done this, then I would use a bracket also. That was not there. Guys, so I'm caught between negative A and a positive A. I think from my example, I was caught between what? Negative 2 and a positive 2. That's the answer. Now, what does that really mean? Jonathan, that really means that x, we're trying to solve for x falls between negative A and positive A. I can write like that. Says the same thing. X is in between. It's in that interval. It's caught between negative A and positive A. Beautiful. I'm gonna come back to that here shortly. Corey, you helped me out so much today. Here we go. Now, number 2. The absolute value of x is greater than A, not necessarily just a 2. And he told me earlier, I think you said now you're looking for when is the red above the green. And tell me now how might you write, when is that happening here?
From negative infinity to A, negative A.
Negative A. Union?
From A to positive infinity.
I love that. You guys agree? That's what it means. If you look back where I used the 2, you sort of see the same thing with the 2 there. Now, we know, all of us know, when I say negative infinity, or Corey says a negative infinity up to a negative A, you're saying this, x must be less than negative A. Is that what negative infinity up to a negative A means? X is less than negative A. Then he said, or, I'm gonna put the word or, union. Now what's another way to express this, just a little common sense, if it says A through infinity, what are you talking about?
Always greater than.
Everything to the right of, greater than, thank you. And with his help, I have now another conclusion that's going to be a big time help based on, I should put his name up here on the board. This is Corey's theorem. It looks like it may work out for us. Now, Corey, look what you've done for the class. Now, on the side here, I like to solve with his help. First one, absolute value, let's make it 3x minus 1, reading one right quick, you guys, less than 4. And I don't want to graph, oh my goodness, I'm not going to graph another V-shaped graph, horizontal line, not going to go through all that business. Can anyone tell me, based on Corey, how can I set this up? Guys, absolute value 3x minus 1 is less than 4. He's giving me 2 statements. He says, Professor, if it's less than, which mine is in this first example, use this rule. That's what he told me. If it's greater than, which is right there, which mine's not in this case, use this form. Therefore, which form am I going to use? Since it's less than A, absolute value, X is less than A, means this. You wouldn't believe how easy he's made it for us. Now, can someone tell me real quickly, drop the absolute value bars. Can anyone tell me right quickly what Corey just did for us? Please tell me, what does that mean? And Corey did it for us. What does it mean? And right here, he gave me earlier, he says, Professor, if it looks like this, which mine does, then you write up right quickly, with his help, you write up right quickly, Professor, is this. Now, let's make a statement and tell me right quickly, no absolute value bars, tell me what does that mean, Leo? Tell me about Corey's thing here.
3x minus 1 is greater than negative 4, but less than 4.
Okay, I like it better some other way, right? In the specific,
Negative 4
specific
is
form.
less than 3x minus 1, which
Tell me-
is less
Hang on,
than
hang on,
4.
tell me again,
Negative 4
negative 4,
is less than 3x minus 1,
beautiful,
which is less than 4.
look at that. That's what he's telling me over there, the absolute value bars are gone. Corey's already told us what it means. That's exactly what it means. Now you gotta solve that, of course, for X. Thank goodness I can do this one fairly easily done to solve for X, guys. I'm gonna add 1. All parts here. And guys, if I add 1, if I'm careful, I'm gonna end up with negative 3, looks like, is less than, these ones cancel, 3x is less than 5, check my arithmetic there, trying to solve it. And what's my last step to get the x or solve it? Divide by 3. Thank goodness that 3 is positive, no symbols reversing on me. Divide by 3, everything by 3. So you're going to end up with negative 1 is less than, these 3's cancel, x, which I want, less than 5/3. Corey says, Professor, when they say solve for x, that's the answer. Anything caught here, we'll satisfy that. Jonathan, real quickly, give me something, first let's put in interval notation. Tell the class what this looks like written in interval notation.
No. What is that?
In fact, it's much like what we're doing here.
It's just
Corey.
negative 1 to 5/3.
There you go.
Negative 1 to 5, open paren, like on both ends.
There you go.
Yeah.
Absolutely. Much like what he was doing for me back here. Now, there's lots of numbers caught between negative 1 and 5/3. How many? Infinite. There's an infinite number of numbers caught between negative 1 and 5/3. Give me one. It's caught between, I'm gonna test it, 0. If I'm guaranteed then, if I put a 0 in here, it better satisfy this. If I put a 0 in, 3 times 0 is what? 0 minus 1 gives me a negative 1. The bars makes it a positive 1. Is positive 1 less than 4? You get outside that interval, will not work. Jonathan, give me something outside.
Let's do, yeah, I can do 3.
I could do 3. That's not in there. 3. What's wrong with 3? 3 times 3 is 9. Minus 1 gives me an 8. Those bars, absolute value, we're making an 8 coming out. Is 8 less than 4? No. So all those numbers you see on the board are the ones that will work. Others outside will not work for this problem. Wow, nice. Number 2. Now I think I brought some in here. Let me see if I can. Jonathan, that beautiful handout that I just passed out. Did I have something like, let's do one with, oh, I got it. Was there an absolute value of 2x plus 5, something like that? Okay, I'm gonna change the symbol. I think on the handout it says less than 7.
Yeah, it does.
I'm gonna change it for a reason. And I'm gonna write like this. And watch carefully. You're gonna solve that equation for x. What can I replace x by and be guaranteed it works? Nice. Now, Corey, theorem is over here. Based on the way that thing's written, am I gonna go to this?
No,
Or does it look like more like this?
more like that.
This one. It's a greater than. That's why I changed it. Now, if it's a greater than, you gotta write like this. Like Corey's reasoning. Can anyone tell me, based on his reasoning, it's gonna take two parts? Can anyone tell me the two parts here that I can translate, drop the absolute value bars, translate and tell what it means? Leo, go for it.
Maybe -7 is less than 12x plus 5.
Hang on. Please write it in the form he gave me. I'm gonna stick with Corey. He says x is less than -a. Apply that to my problem, what does that look like? And the x was the inside part.
2x
Say,
plus 5.
whatever's inside, Professor, that's x.
2x plus 5 is
There you go, inside is 2x plus 5.
less than or equal to -7.
Hang on. Is less than what?
Or equal to
Or equal to this, okay, equal to what?
-7.
-7.
And then 2x
Now, but or union,
2x
and-
plus 5 is greater than or equal to
I'm
7.
gonna say it is, I gotta write like this. I gotta write like Corey. X is greater than a, what does that look like here?
2x plus 5 is
2x plus
greater
5,
than or equal to
look
7.
at that, greater than or equal to 7, was it 7 over here? Oh, it was. Hey, is that what it looks like? If I apply Corey's work to it? Yes, no?
Yeah.
Okay, and you solve each one. You can't go wrong. Guys, if I solve this one, no problem. 2x is less than or equal to a -12, I'll do it quickly, divide by 2. X is less than or equal to a -6. I did it quickly. This one, if I solve it, move the 5 over, subtract 5. You're going to end up with a 2. Oh, that's not bad. X is greater than or equal to 1. There it is. Now you know, to finish this up and then we'll take questions. Corey tells me, Professor, it could also, the answer could also be written like this in interval notation. I'd like to express this one also in interval notation. So guys, tell me first, let me go to this one. Does anyone have any idea? We put it in a different color so you can see it.
Open, negative infinity,
Thank you. Open, negative infinity.
comma -6, close.
Thank you.
And then union.
Union.
Close, close 1
Bracket 1.
to infinity.
There's your math done. There's your equation solved. John,
So, every time I see any like linear function or anything in those absolute values, it doesn't matter what it is, you can just think of it as
that's Corey's.
x or.
Just like the X,
Yeah,
yes.
it's just, you can just think of it as.
Absolutely.
And you can just, yeah.
That's why I love this. All that, I realize it's just an X over here in what he was telling us. But that just represents everything inside here.
Yeah.
Everything, that's my X. 2x plus 5 is my X. That he was talking about. It's set up, you got an A. You got the answer. I gotta see my time, almost run out here. Corey, you saved me some time here today. I thought I was going to spend more time on it, and all of a sudden you came up with this, which was a big help. I think it works out. I think you made the students happy. Those two statements. Okay? Next one, and then we're going to take a break. Number 3. Squeeze that in right here. Absolute value of x is less than a -9. Now, I'd like to know what should I apply here to get my last example worked. Absolute value of x is less than -9. So should I go to Corey's and use number 1 maybe? Was that the first statement he made?
No, that's no, because the solution.
Oh,
Yes.
oh, before the breakers and Ramsey, they're trying to trick us here. This one has no solution. Don't even attempt it. Why can I not turn to Corey's, like that business there? Can I have absolute, you know what absolute value looks like? It's that V-shaped graph. Here it is.
Always.
My goodness, I'm saying less than -9. -9 is down here. If you want to see a picture of what's going on, -9 is down here. And Corey tells me that this means when is my red graph below -9. Is that red graph that I had up here for absolute value, is it ever down here below? I can't solve it. There's no answer. Makes no sense. There.
If you had given us an absolute value with like a transformation of put a -10 outside the absolute value, then it would be a little.
We'll do one of those after the break. I know what you're talking about. Guys, it's help.
Yeah.
Now, this is conclusion of chapter 2. I'll say a few more things after the break. Yeah.
What if absolute value of x is greater than -9?
Whoa, Leo. Oh, Lord, I wish other teachers could hear all this. Here we go. Now, you said, Professor turned around. Wow. Now, keep in mind, Corey says that means, I should ask Corey. Corey, tell the class again, what does that mean first? In terms of that red graph.
When is it below or above the?
Yeah, but in this case, he said put a greater than symbol. So what does that mean? When is a red graph above -9? Look at this now. That's what it means. When is a red graph above -9? I know and you know -9 is down here. Is my red graph always going to be above? Oh, Leo, mathematician. What's the answer?
All real numbers.
All real numbers. And many textbooks will express it like this. Everything works. Everything works. All real numbers works. Wow. Anna, Park, if these students are not ready for Math 7, because I'm gonna check on them in the spring, you'll probably be receiving a message from me. I'll let you maybe go into the spring semester, maybe 4 weeks. That'll be enough time for everyone to have their first calc test. And I'm gonna check on you. I'll send you an email and ask you first, how are you doing? And then I'll ask the professor, how you're doing. So if you're saying, I'm doing well, professor, got 100 on the first test, and then I check with professor, because I know all these professors, I check with Professor so-and-so, and Jonathan told me he got 100 on the first test. Not quite. I said, well, what? He told me he got 100 on the first test. Randy, no. I said, whoops. So I will be checking. Guys, any concerns here? Corey, big time help here. Guys, take your 15-minute break.